Okay, so question 8 here is worth 55 marks. So I might split it up. Oops. There's, so we have an A, B, C, I'm guessing, okay, D. So maybe I'll do A and B first, and then we'll do C and D together then. Okay, so question A said, a swimmer is on a starting block at the beginning of race. When she dives off the block until she resurfaces, the level of the swimmer relative to the level of water is given by the function h of x. Okay, so h of x, and x is the horizontal distance in meters of the swimmer from the block. Okay, then they tell us that we're only looking at this function between x values of 0 and 12. And it says that where x is an element of r and h of x is measured in meters. Okay, so it says find the height of the block above water. So how are we going to do this? So x is the distance of the swimmer from the block. So if the swimmer is on the block, she has an x value of 0 meters from the block. So we can find h of x, the height of the swimmer, when she's on the block by filling in that x is equal to 0. Okay, so h of x is height of the block. So I'm just going to write this in for you guys. So height of block if swimmer is on block. So if swimmer is distance of 0 meters from the block, okay, because h of x is the swimmer's height above the water. So if the swimmer is 0 meters from the block, so that means that x here is going to be 0. So we can find h of 0, which is 1 over 60 times 0 squared minus a quarter. Oops. So minus a quarter times 0 plus 3 over 5. So anything multiplied by 0 is just going to give me 0. So the h, the height, is going to be 3 over 5. So the block is 3 over 5 meters above water. Okay. Part 2 then says, show that the swimmer is on the surface of the water, i.e. h of x is 0, when she is 12 meters from the starting block. Okay, so if we have a look at this function, guys, this is a function that shows the swimmer starting off on a block. So starting off maybe up here and diving into the water and then coming back up. And it stops when she reaches the surface of the water. Okay, so what we're looking at here is her, this is like the x-axis. So her y value here, or her h of x value, is equal to 0 at both of the points where she is at the surface of the water. So h of x is 0 here and h of x is 0 here. Okay, we don't even need to realise that because it actually gives us that h of x is 0. Okay, and then it says she's 12 meters from the starting block. So 12 meters from the starting block. 12 meters from the starting block, let me just make sure I'm still recording, means that her x value is equal to 12. Okay, and then it told us that h of x is equal to 0. So we can just fill these into this equation up here and see if the equation works out. Okay, so h of x I'm going to fill in as 0 is equal to 1 over 60. And then it was x squared, so 12 squared. Minus 1 over 4 times x, so times 12, plus 3 over 5. Okay, so I'm going to just do this out with BIMDAS, just in case I've done something wrong that maybe I'll get some marks somewhere. So with BIMDAS, I can't simplify inside my brackets, but I can do my indices. Okay, I can look at that squared number there first. So if I do that, then I'll get 0 is 1 over 60 times 12 squared, which is 144, minus 1 over 4 times 12, plus 3 over 5. So when we do this out, so we're going to have 12 over 5. So 0 equals 12 over 5 minus 3 plus 3 over 5. So that's going to give me that 0 is equal to 0. Okay, so we have shown that when x is equal to 12, so her horizontal distance from the surface of the block is 12. So let me just kind of add this into my little diagram up here. So this is 0. So when she's 12 meters away here, so when my x value is 12, she was at the surface of the water. Okay, then it says find the horizontal distance in meters from the starting block to the point of where the swimmer enters the water. Okay, so we've found when she resurfaces back up. Okay, so we want to find that initial point. So if we find the two roots of this, the two places where h of x is equal to 0, one of them will be where she enters and one of them will be where she hits back up to that water. Okay, so I'm going to fill in. So I have h of x was 1 over 60 x squared minus a quarter times x plus 3 over 5. Okay, now just like if I had an equation where I had something like 6x squared plus 36x minus 12 is equal to 0. Just like when we had something like this and we said it's much easier for us if we divide, if we can kind of get rid of this coefficient of the x squared, that it's, if we can make the coefficient of the x squared 1. So like in a situation like this, we can divide everything across by 6. We can only do that if there's an equals in the equation, but here there is an equals in the equation. So what I can do is, so I want to find the places where that is equal to 0. So what I can do here is to get my coefficient of the x squared to be to 1, I can actually multiply everything, every term in this quadratic by 60. Okay, so I'm going to multiply the 0 here by 60. I'm going to multiply the 1 over 60 x squared. I'm going to multiply that by 60. I'm going to multiply by my minus a quarter x by 60. And I'm going to multiply my 3 over 5 by 60. Okay, so what I'll end up with is 60 times 0 is equal to. Then I'll get x squared minus 15x. And then 3 over 5 times 60 is 36. So plus 36. Okay, so now I'm just going to be able to solve this as a quadratic. X squared minus 15x plus 36 is equal to 0. So we're finding factor pairs of 36 that are going to add to give me minus 15. So I'm going to have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, now they are multiplying to give me a plus, which means I need to either multiply a plus and a plus or a minus and a minus to multiply to give me a plus. So to get them to add to give me a minus 15, I know I'm going to have to use a minus and a minus. Okay, so I'm going to end up using a minus 3 and a minus 12 here. Okay, so I'm going to open up my brackets to factorize and put my x as my first term in both brackets, and then I had a minus 3 and a minus 12. So both of these x values, when I get these two x values, are going to be the values and the distance of the girl from the block that she dives off when she's at the surface of the water. So I have x minus 3 is equal to 0. So when she is 3 meters from the surface of the block, and then the x minus 12 equals 0 is the x minus 12 that we had when she resurfaced to the water after her dive. So when she's 12 meters away from the block, that's after she dives, is underneath the water and gets back up to the surface, is at 12 meters. Okay, so I want to show that I know that where she first enters the water, okay, so it says where she enters the water is this first one here. So x is equal to 3. So I'm just going to put a box around it there. Okay, so that is that one. Then part B says find h prime of x, the derivative of h of x. And it gives us h of x there. So this is nice and easy. We know how to derive that function. So we have h prime of x. So we multiply by the power and then reduce the power by 1. So 1 over 60 by 2 is 1 over 30. 2 over 60 are 1 over 30. So it's 1 over 30 and then x, and I reduce the power by 1, so my power is just 1. And then I have minus, again here my power on the x is a 1. So a quarter is going to stay as a quarter. And then my x is to the power 0, so I won't write it down. So that is that derived. That is worth 5 marks. Okay, just this here. Then this gives you a little bit of a clue on how we're going to do part 2. So it says use your answer to part C, part 1, to find the horizontal distance x in meters from the starting block to the point at which the swimmer reaches her greatest depth. Okay, so remember this is our curve for her diving off the block. Okay, so it wants us to somehow use the derivative. So remember the derivative is the slope. It's talking about the slope. So how are we going to use the slope to find what this greatest depth of the swimmer is? How are we going to use that slope? Well, let's find the point where her slope is 0. So if we find that, what we'll get is this minimum point. Okay, so remember, to get the minima and maxima, or the minimum points and the maximum points, we are letting the derivative, the slope, equal to 0. So we're finding the tangent that has a slope of 0. Okay, so I am going to let h prime of x equal to 0. Okay, so I'm going to say that, and then I'm going to find what the x value is here. So x is equal to what? So let's have a look. So 0 is equal to 1 over 30x minus a quarter. Just make sure it's still recording. Fab. Minus a quarter. Oh no. Okay, I've just figured out what happened. My bobbin's hitting off the thing. Okay, so minus a quarter. So we just want to figure out what x is in this situation. So we are following SADMIB to figure out, to get x essentially on a side by itself. Okay, so I'm following SADMIB. What's in the way of getting x on a side by itself? Well, there's a subtraction in the way. So that minus a quarter, we want to get rid of that. So I'm going to add a quarter on. So I'm doing the opposite of the minusing. I am adding a quarter onto both sides. So I'm going to be left with there a quarter is equal to 1x over 30. Now I have in the way of the x on a side by itself, I have a 30 that's dividing. So how do I get rid of a 30 that's dividing? I multiply by 30. So I'm going to multiply both sides by 30 to get that x is equal to 30 over 4 meters. So we can simplify that down to 15 over 2 meters, or we can say 7.5 meters. Okay, so when she is 7.5 meters away from this starting point, so 7.5 meters here is when she is at her greatest depth. And then it says, hence find this greatest depth. So we're going to find the distance from the the distance. So we're going to find the y value at this 7.5 x value. So I know that h of x is equal to, it has it up here, it has it up here at the top, so it is equal to 1 over 60 x squared minus a quarter x plus 3 over 5. So I'm going to fill in my x value there of 7.5. So h of 7.5 is 1 over 60 times 7.5 squared minus 1 over 4 by 7.5 plus 3 over 5. So we can do that out with BIMDAS. So the first thing I'm going to do, well, I can't simplify inside my brackets at all, but I do have an indice here, so I'm going to do that. So I'm going to square my 7.5, and I will fill in here. So 1 over 60 times 56.25 minus a quarter by my 7.5 plus 3 over 5. Okay, so 1 over 60 by 56.25, I get 15 over 16. And then minus a quarter by 7.5, so minus 15 over 8. And then plus my 3 over 5. Okay, so when I do this into my calculator, so 15 over 16 minus 15 over 8 plus 3 over 5. And we get a minus answer. We get minus 27 over 80. Okay, so that is her height relative to the surface of the water. So it asks for her depth, so we don't really put the minus in. Like if your height is minus 5 meters from the surface of the water, that means you're at a depth of 5 meters. So here she has a depth of 27 over 80 meters. Okay, I'm just going to stop that there, and then I'll do D and E in another video.